Hey,
Hello,
hi,
hello.
how's it going?
Pretty good, pretty good. How are you?
You feeling better, hopefully?
Yeah, slowly getting back to normal condition. It was it was rough.
That's tough, man. One of my coworkers just came down with COVID, I guess, yesterday as well, and they're hit pretty hard. So it's still a real thing.
Oh yeah, oh yeah. It was actually interesting. So I probably got it from a vacation trip. You know, crowded planes, airports, the usual stuff. And
Yeah,
it was the third time I had COVID, and this was by far the worst one.
really. Oh man.
Yeah. I would have thought that, my body has some antibodies still left or something, but no. And as
Well,
as usual, the whole family got it. So we had an interesting time.
of course they did.
Yeah.
Well, I hope you're feeling better and continue to be on the mend. Um, and thanks for joining.
Morning. Hope everyone is doing great.
Hi,
Right.
we're all doing great,
Well, good
Ricardo.
morning, good evening. Maybe some of you are in Europe. UC is probably in Europe. So.
Yeah. I'm in Finland. So we
Nice and
have
warm, right? Nice and warm, right?
yeah, right. We have a lot of snow. We've got like, I don't know, like half a meter in the past few days. So I've been doing a lot of snow shoveling.
Oh wow.
That's
Well,
fun.
no, it's only nice in the beginning, right? When the snow falls, it's all pretty and all that. But then once you have to shovel the snow, there's like, oh my God, I don't want to live here.
Yeah, exactly. Exactly. And then especially when you have to do it like 2 times a day, then it's like, oh God,
Yeah.
why can't I move to like
Yeah.
somewhere, Florida or something?
Yeah.
But then you'd get hurricanes and all that stuff. So, you know,
There's always trade-offs, right? So depending on where
yeah,
you live.
absolutely.
So I put the link to the agenda in the chat. If you wouldn't mind putting, I think your name, a lot of your names are in there already, but if you wouldn't mind adding your name and adding your affiliation of any kind, if you have one, that would be super helpful. Um,
Yeah, I'm basically sharing my screen. So basically this is here. And
Perfect. And we do have two agenda items today, although I don't see Alan here from Drasi.
Alan will be joining us shortly.
Okay. Oh, thank you. Hi. So because there's two slots, we usually try to keep it around 25 minutes for each. That's okay. If you do run out of time, you're welcome to come back to a later session and finish or talk again. Anything you wanted to do that might have been missed or continue the conversation. It's more than welcome to do that. Um, and with that, I think let's hand it over to Jussie.
All right. Thank you. Let me try to figure out how to share my screen. I have few slides I wanted to show and kind of talk about K0s a bit, and then I have a live demo. So you know how live demos might go. So
We love them. Yes.
oh yeah. Why is the share stuff so different always in different tools? Okay.
Yeah. Very cool.
All right. And if I do you still see the slides?
Yeah, looks great. Looks
Yep.
great to
Okay.
me.
All right. Very good. Very good. All right. So Uh, I'm planning to share a quick-ish intro to what K0s is and what it's not. Then, like I said, a quick live demo, then talk about with the roadmap, adoption, community, and those kind of aspects. Of course, given that we have very limited time, I'm not going to be able to go super deep into different areas, but like Steven said, we can then continue the discussion on selected areas when needed. So basically, K0s is a kube distro, and one of the kind of design goals that we had from day zero for K0s was that we want to have something that you can super easily put into any infrastructure and it just works. And it's basically a single binary that you can drop into any environment, just run it, and you have Kubernetes at your hands. Of course, in real life, we know that it's not that simple always, but in the simplest cases, that's how it works, and that's what I'll show in the demo too. So, like I said, K0s is a single binary, comes with all the Kubernetes and other needed components in it. What it means is that there's no dependencies on K0s per se. Of course, there are dependencies to have like kernel modules loaded so that you can run the typical networking stuff. Your kernel has to support C groups and other container constructs and those kind of things. But that's something you'd anyway expect in a modern-ish kernel and modern-ish Linux operating system. What it also gives us is a very nice distinction between the operating system stuff and the Kubernetes bits, because now we don't have to rely on operating system providing packages for separate versions of Kubernetes and those kind of things. So we can fully decouple the Kubernetes upgrades and the operating system upgrades from each other. All the needed batteries are included. Containerd is the default runtime that we ship with K0s. Kuberouter and Calico are both supported as CNI. We support, of course, etcd, but we also support Kine as the kind of backing data store for the API server, which gives you the ability to use SQL databases like SQLite or MariaDB or Postgres or whatever. And of course, everything can be swapped to your favorite solution. So you can run K0s with, say, Docker daemon as the container runtime, or CRI-O, or whatever runtime you want to run. But of course, that's not shipped with K0s itself. So that's something you have to then install yourself and then just point K0s to use that runtime. Or you can change to your favorite networking solution like Cilium or something else. One of the architectural differences to pretty much any other kube distro is the fact that by default, when we create the control plane nodes with K0s, we actually get pure controllers. And what I mean by pure controllers is the fact that we don't actually run by default kubelet, containerd, or any workload related things on the controller nodes. So it's just the control plane. Kube API server, etcd, scheduler, controller, manager, and those kind of bits and pieces. And then when we attach the worker nodes into the cluster, we actually deploy a component called connectivity. That's under the SIG API network proxy working group, SIG. I'm not sure which one it's actually called, but anyway. And what that does is the agent running on each of the worker nodes actually calls home to the control plane and establishes a TLS tunnel. And then we configure API server in a way that whenever API needs to go back to the nodes, like to get logs or exec into pods or those kind of use cases, it actually goes through this tunnel towards kubelet. And what this really allows us to do is kind of segment the control plane and worker planes in very different environments and or even geographic locations. One of the classical examples I use for this is that with this architecture, what you can actually do is you can run the control plane, say, in a public cloud, expose it through some Amazon ELB or whatever, and then you can actually run the worker nodes in your private data center, as long as the worker node can kind of call home and establish the TLS tunnel to the controller, and everything works out of the box. So it really kind of opens up a whole new door for different kind of deployment architectures, and especially towards use cases like in edge environments and IoT and those kind of environments and use cases. And then one of the kind of use cases is also the fact that when we have a pure controller node which cannot run workloads, then nobody can actually schedule workloads on the controller node even by accident, because Kubernetes doesn't really have any controls to say that, okay, Jussi is not an admin, so he cannot actually deploy workloads on a controller node. I mean, yeah, of course you can do that using different policy controls like Kyverno or whatnot, but you'd have to do like custom policies. So there's no like RBAC capabilities out of the box for that. Stephen.
So does that mean there's no like ability to configure that? Like, say you really wanted to run something on the control node, you can't say like go ahead and schedule anyway or override the default?
You can. So there is a flag where you can say that, okay, we are running a controller, but let's also enable the worker parts. You can do that. And that's quite common what people do, because that's the kind of what I call traditional deployment architecture, and many people and organizations are used to do that.
Sure. Okay. But by default, it would not allow that.
Yeah.
Cool.
I have a question. So what are the memory CPU requirements for the control plane, or what is the footprint? Or are you going to talk about it? Or?
I have a slide on that coming up in a bit.
Sounds good. Yeah. I think Victor has a question there.
Oh, hey. I wanted to add, I actually end up using K0s a lot for some of like my stuff, and I found that like one of the nice things is that you can do this sort of single node version, which is like, I think for many more deployments than people would like to admit, is more than enough for a lot of people who are doing things on some of the larger, some of the clouds, like whether it's on a hyperscaler or just locally. Like
absolutely,
you just get a massive Hetzner machine and run K0s single node on it. Like obviously it's really easy to use across multiple machines, but sometimes it's just like that's enough, especially for like test clusters and stuff like that. But
yeah, absolutely. And the kind of that single option that you're mentioning here is kind of an optimization where we run the control plane, yes, but we also optimize it to be a single node control plane. So we automatically swap out etcd to Kine and local SQLite database and all those kind of things. So it's kind of like a single node optimized use case for sure. And like you said, in many cases, it's more than enough. All right. One of the kind of built-in functionalities I wanted to highlight is a component called what we call autopilot. So autopilot is really a controller or set of controllers that lives on K0s itself. And what it actually does, as the name implies, it can update the cluster by itself. So and of course, as in we're talking about Kubernetes here, so everything is naturally CRD driven. So what you can actually do is you can create a custom resource called plan and basically say that, okay, I want to update to this version. Go ahead and do it. And then autopilot figures out that, okay, let's update the controllers first, one by one, wait that everything comes up healthy, then goes on the worker nodes and the normal training, cordoning dance, what I call it. So trying to keep the cluster as safe and as alive as humanly possible during the upgrade. What I always mention is that we can control the availability from Kubernetes point of view. Whether that means fully 100% availability for your applications, then it's like a different story. Ricardo.
Yes, a question about redundancy on the control plane. So, I mean, you have upgrades, so that means like, is it a single node, or you have the option to have multiple control plane
Yeah.
node?
Absolutely. So K0s, one of the things that because like I said in the beginning, which I should have been more clear, one of the things that K0s comes with is etcd itself. So K0s manages the etcd also. So that's why the autopilot does the controller node upgrades one by one, because it's etcd and it's picky about things.
Got it.
And the etcd that we configure is also what I call like elastic in a way, that you can start with one controller node and later on you can actually add controller nodes, and K0s knows how to reconfigure etcd and the clustering on it.
Got it. Yeah, I was just thinking about edge applications too. Like some of these edge locations don't have multiple pieces of hardware, so they just have like a single server. So when you do the upgrade, the workloads actually continue to run basically, and then I guess if they have like a single controller head node basically. So they continue to run, right? So
Yep.
it's not. Yeah. Okay.
Yeah.
Okay.
I mean, it's typical Kubernetes still. So
Yeah.
when even if the control plane goes down, your workloads continue to run.
Got it. Yeah, because I've seen some cases where, I mean, I'm talking about K3s too, which is kind of similar to, like, some people are running this as a single head node because of like edge constraints or just the nature of the environment. Maybe they want to save costs and they just have like a single node.
Yeah. But what I've seen with K0s more and more when like in the past year, couple of years already, because we do have this controller worker full kind of separation isolation. What I've seen actually people go more towards in these kind of edge-like use cases is that the controllers are actually somewhere and the edge nodes are pure worker nodes.
Got it.
Because like you said, edge use cases typically comes with the fact that your resources are very, very constrained.
Yeah.
So you don't actually have capacity to run the control plane on the edge per se.
Yeah, I think it's just similar to the pattern that KubeEdge uses, which is, they have control plane like in a centralized location, and then each one of the nodes are actually in some constrained location at the edge, and they connect to that centralized location. Yeah.
When you talk about the upgrade or the update operator, is upgrade more than just like restarting the K0s binary? How do those relate?
I mean, essentially it boils down to getting the new version of the binary and restarting. Yes. But of course, there's kind of orchestration and all the cordoning, draining, all that stuff kind of involved in that process. So we can't just go and blindly restart everything at once. So there's kind of logic and coordination going on.
Gotcha. So the operator would be more of like the multi-node orchestration piece of and to restart it.
Yeah.
Awesome.
Yeah.
Cool.
All right. So the focus from basically day zero has been like simplicity for the operations. We manage etcd, it's dynamic. We can add, remove easily. There's an asterisk there. I mean, it's etcd, so you have to be careful. We have a neat way to have like these what we call worker profiles. When you have like specialized worker nodes, you can say that okay, this is a worker node and this runs with this profile, And the profile gives you ability to configure very, very low level kubelet configs and those kind of things. So you can kind of fine tune a specialized node, for example. We have a feature where you can easily drop in containerd config snippets, which we then mangle together for a full containerd configuration. For one example, which we use this for is to drop in additional runtimes like WASM or gvisor, for example. And then of course we do support fully air-gapped setups, and we create in the release process we create image bundles for all the system images for a specific version of K0s. So what it means is that when you're setting up an air-gapped environment, you basically need now two files. You need the binary, of course, and then you need the image bundle, which is basically a tarball of all the needed system images. And you can also bundle your own application images in the same bundle or a different bundle, which we can load automatically into containerd. All right. The system requirements. So controller nodes, it's 1 to 2 CPUs, 1 to 2 gigs of RAM is of course the minimum. But we know that we're talking about etcd and we're talking about kube API server, which both are a bit resource hungry. So and you know, this is the minimum. Of course, things and requirements go up when you have add more worker nodes, where you add more workloads and all that. So for worker nodes, it's even smaller, of course. 1 CPU, half a gig of RAM is proven to work. We had a use case with an European, unfortunately I can't mention the name, but European industrial factory IoT thingy, where they actually were able to run K0s workers on an industrial automation controllers with one very, very slow ARM v7 CPU, and it actually had half a gig of RAM only. And everything actually works. Yes, there is not that much room for your workloads anymore, but in their case, the applications were very, very lightweight, simple data collectors for their IoT things. And we support, of course, x86 64, ARM64, and ARMv7 out of the box. We're currently looking to build RISC-V support too, which would be very cool, but there's some challenges. Let's put it that way. Mostly in the area of CI. That okay, because for us it's not enough that we just build the packages for RISC-V. We actually want to get them through testing and all that stuff. So building a CI for RISC-V seems to be very difficult currently. All right, demo time.
And just a quick time check, about 7 minutes, maybe, Drasi?
Yeah, okay. So I'm doing the nasty thing here, of course, piping a script from internet to my box as root, which you shouldn't do just for the recording. I know what the script is, and of course you should investigate and probably do things, but just to save time. And what the script actually does, it just figures out what's the latest release and downloads it automatically for the correct architecture and those kind of things. So I have the binary in place, K0s install controller. And the install command is basically just a wrapper to create the systemd unit for me automatically. K0 start, again, just a wrapper for systemctl, yada, 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 to make life easier. We also do support OpenRC. And if we look at the processes, we have K0s running in a controller mode, and it actually booted up all the etcd API servers, schedulers, controller managers, everything. So essentially, K0s is just a glorified watchdog for all the Kubernetes components. And of course, knows how to set those up. So, all right. So to be able to actually join a worker node, kubectl get node. So I don't actually have nodes because I don't have kubelet running anywhere yet. K0s token create worker. It'll spit me out the token, which as you can see is base64 encoded stuff. So the kind of ergonomics of the initializing a controller, joining another node, it's pretty much similar process, or I would say exactly the same process as kubeadm does. With kubeadm, you initialize things, you get a token, then you can join other nodes. I mean, of course, the commands are a bit different, but the kind of general ergonomics are the same. All right, let's hop to the worker node. K0s token. I'm just going to put the token in place for the worker node. K0, I need to download it first. All right. K0s install worker token dash file is etcd K0s token. So I'm not doing any configuration of anything. Of course, I could go and configure a lot of things like for the CNIs and whatnot, but I'm just going with the plain defaults here. And then K0s kubectl get node. Oh, I need to start it. Oh God, where are computers smart today? All right. So the worker has already joined to the control plane. It's not ready yet. It's pulling some images and all that stuff. But as you can see, it's K0s makes it super easy to create nodes. And then if I would be upgrading things, I could just need to get the new binary and restart, and that's it. And plus, of course, the training coordinating stuff, if you need to do that or want to do that.
That's very cool. Can I ask you, if you have multiple control plane nodes, do you get an actual node at that point for the control plane? Or control plane never has an actual Kubernetes node? Like as far as a
Yeah.
get node.
Yeah. So if when you run plain controller nodes without the enable worker or any such flags, you never get a Kubernetes node object for that.
Okay. Nice.
All right. Maybe I'll highlight in the last couple of minutes some community aspects. So we do collect anonymous telemetry, which can be, of course, super easily disabled. So what we've seen since the early days of our telemetry, we have 440K installations. Of course, most of them are not online anymore, but that's the kind of unique number of clusters we've seen. And the kind of weekly active cluster count hovers around 10, 11K at the moment. So there's quite a bit of community adoption.
This is great. One question: are you looking to apply for incubation or at some point?
Sandbox.
Or just sandbox? I thought you were in sandbox already. No.
Nope.
Okay. Okay. Cool. Yeah,
So-
I mean, yeah, for some boxes it should be fine. I think in terms of adoption, right?
Yeah, yeah. I think our thinking is that sandbox allows us to do. I mean, during the sandbox time, what our main goal is to establish more on the community aspects like governance and those kind of things.
Yeah, so there is some like the sandbox requirements are not very strict, but as you go into incubation, yeah, you'll need you know, like governance around the
Yeah.
project, like different files in the repo, like adopters, maintainers, and so they ask for a few things. And I think there's also some due diligence of adopters, but I mean, it's something to consider in the future. If you have, as you gain adoption and you gain end users, specific end users, then in the due diligence document, it is required, they're required to add some end users, like the specific end users.
Yeah. I think we actually have most of that already documented and everything, but I think for us the sandbox makes sense, and hopefully our sandbox period would be actually quite short.
Makes sense. Thanks.
That's what we're thinking at least. Contributors. So we have like 3 to 4, depending how you count it, kind of full-time maintainers at Mirantis, and then on Replicated, they have 2 to 3 kind of part-time maintainers also collaborating with us on the kind of day-to-day maintainer activities. And then of course, as for any open source project, we get some amount of like random-ish contributions from the community. Of course, most of them being issues and some fixes and smaller things. Altogether, we have currently like 100 individual committers to the project. We do have a separate repo for the community stuff, like the code of conducts and things like that. The governance parts are very work in progress still, but that's kind of the pattern that we want to follow. That okay, we document everything in a community repo, and then from other repos like the K0s repo itself, we refer to the community repo, so that we don't have to copy paste the same stuff all over gazillion repos, and then tomorrow some one of them is already out of date, and you know how it goes.
Awesome.
Thank you.
Yeah,
great.
that's all really good, Drasi. Thank you for showing this to us and presenting today. Appreciate it.
No worries. I'm always happy to share what we're working on, and like I said, if there's need, I can hop on another call.
Yeah. Quick question from Victor.
Oh yeah, sorry, I'm a little bit late here, but I wanted to, like, I most of my sort of K0s usage comes through the CTL tool, the K0s CTL. I know that didn't come up in the demo, but I wanted to just drop a link. Should I drop a link in the doc, like under that? So it's like the it's sort of like a declarative CLI tool for managing like a cluster of machines.
Yeah, why don't you throw it in the notes, the doc, put it in the chat here as well, would be great.
Yep.
Oh yeah, let me drop in the chat. And then the one I actually, the actual question I had was around Cosmotron, or well, I'm just calling it Cosmotron, but I'm not sure exactly how y'all pronounce it. And I was wondering if you wanted to say a little bit more about that, because I know it's relatively recent, and sort of like there are a lot of Kubernetes and Kubernetes solutions out there, and I know that just like K0s has been so easy for me, like it's kind of like I don't know. I was like, oh, this is probably going to be 10 times easier than most other things that I'm going to try and like run if I want to do like the, just Kubernetes all the way down, manage the control plane from another sort of larger cluster. So yeah, I wanted to hear more.
Just to keep it super short in the time slot that I have. So Cosmotron is basically bringing the the like multi-cluster management capabilities, and of course integrates with Cluster API to manage K0s clusters. And one of the features Cosmotron has, because of the K0s architecture, that we can have these separated controllers, is that Cosmotron can actually spin up the control planes in the management cluster as set of pods and stateful sets and services and whatnot. So kind of Kubernetes in Kubernetes in a way.
So yeah, please check out the link there, and appreciate all the questions. We do have to move on to our next presenter now. So thank you so much. And over to Alan for Drasi.
Okay, let me just get things turned on.
Hey, Alan, how's it going?
Hey, how are you guys?
Hi.
Good.
Okay, I'm going to try and share something here. Are you guys seeing that?
No.
Okay, how about
Now it's starting. Now we can see.
you can see it now? Are you seeing it in like full screen presentation view? Or are you seeing it?
No, not. We're seeing the presenter's view.
Okay,
I
let
think
me try
there's a
a
button
different
that says
approach.
swap displays. There was like a button called swap displays in the previous screen.
Okay, 1 second. I'm a Zoom novice. Not even share now. Okay. I'm just going to try and share that desktop, which will be blank for a moment. Get here and do this.
Yes.
Perfect. There you guys. Yes, excellent. Okay. All right. Sorry about that. All right, guys. Hello, I'm Alan. I am the engineering manager of the Drasi project. So I'll just jump straight in. We've got a bunch of Drasi folks here who've come to be available to answer questions and sort of see what's going on. So just jump in straight in. So the whole premise of Drasi comes from the understanding that companies use a lot of complex systems that are usually backed by large and growing databases. And as well as the functionality that's inherent in those systems that they're typically used for and the databases are designed for, there's often a need for organizations to detect and react to when that data changes. And often the system itself doesn't really provide that facility. Some do, many don't. And even if they do, it tends to be sort of quite simple and often harder than wanted to integrate with other sort of changing data. So, examples of this are all over the place. And, we've probably all built systems that do this kind of stuff. So example being, I might want to notify a manager when someone that works for them is in an area where an event is happening, an incident is happening that puts them at risk. So you can imagine that includes HR databases, it includes facilities, it includes some kind of risk management, some kind of news source, right? So it's a complex combination of things happening in near real time. And I want to be able to sort of send an email, send a text, or alert someone when something's happening. Maybe when an order is ready for pickup. It's instead of waiting a few minutes, maybe it could be a few seconds, but it would need to combine the order system and some kind of physical operation system to detect when customers' cars come in, or integrate with the SMS system when the customer says, I'm here. So all of these kinds of things are very commonplace, they're all over the place. And sometimes, like with these cases, like I want to know when things don't happen. So the lack of change is also possibly interesting. So if a car is due for a service at 100,000 miles or requires a a particular kind of maintenance job that's important and it doesn't happen, I would like to know about that in sort of in a dynamic, sort of proactive kind of way. So for us, the detection and reacting to change and the detection of no change and reacting to that, we consider those to be quite equivalent. Okay, so the usual answers to this, again, we're probably all familiar with these, and we see these three patterns occurring again and again, and I'm guilty of many of these patterns in my career. The go-to, the easiest and the most obvious is polling. So I'll just poll the database, right? And which is usually okay if the polling frequency is sort of not too often, maybe the data is not too large. But if you do that, you're having to have a process that sits alongside whatever system you're building. It's going to periodically poll. You need to, if you want to figure out what's changed, you need to take what was the results of your query. You need to store that. You need to get the next query. You need to compare them. It's complicated and it introduces additional elements into your solution. And that's just the detection part. Then you need to propagate that out through some queuing mechanism or some other distribution mechanism to some other thing that then does something with it. So initially seems simple, but over time it gets more complex. Sort of a step up from that might be changelog processing. If your database supports a changelog, at least it stops you polling, but you still have the problem of managing that feed. You have the problem of keeping the state that was against and comparing it to the state that is now to figure out what's changed so that you can react. And you've still got the, what do I do? How do I react? How do I distribute that? And so the third pattern we see, which isn't usually one people do in order to solve this problem, but if they have a streaming analytics platform, often they'll start trying to use it to do these kind of problems. And sometimes streaming analytics is fine for this kind of problem, and sometimes it's like fitting a square peg into a round hole, and you start having compromises. Plus, most of these things require you to move the data onto that platform so that then you can run jobs across it. It's not really designed for real-time responding to changes. You run jobs frequently. If you run them frequently enough, you can sort of get that effect. But all of these, in our minds, when we looked at all these, it's like, to just do this really seemingly simple thing that I just want to know when that data changes and I just want to do something. And I don't want to be engineering systems, and I don't want to be, having all these extra things running and being maintained. And maybe for 1, 2, 3, it's okay. But if you have dozens or hundreds of these things, it becomes a meaningful overhead on your operations. I guess the other aspect of looking at this is if I want to build a system that does a good job at propagating out changes so that people can hook into these changes, it's actually really hard. Right, and that's why we have these less than satisfactory systems, because doing it right is really, really complicated. You have to start thinking about how you manage the subscriptions or the connections, how people express what they want to understand, how you scale it, how you distribute it. So it's not a trivial problem. So we sort of took a step back and said, well, how would we deal with this if we were coming at it afresh and we wanted to create this platform that's sole purpose was detecting change and allowing you to react to it with as minimal sort of coding and development and engineering as possible. And so we've come up with Drasi, which we call, well, we were calling it something, but we think of it as a change-driven architecture. Right? Instead of event-driven, think of it as change-driven. So the important thing is change, not just things happen, but change has happened. 3 simple concepts: sources, continuous queries, reactions. If anyone has any questions, please jump in. I can't really see everyone, so I won't know, but just yell out. So 3 simple sources, simple concepts: sources, continuous queries, and reactions. Sources, as the name would imply, are our way of connecting to sources of change. And so we have a source SDK in multiple languages so that people can develop their own sources. We ship with a we have already made available a number of sources for things like Postgres, Cosmos Gremlin, SQL Server. We have experimental ones for Kubernetes, that kind of stuff. And there's a bunch more that we've got in various states of completedness. But really, a source just it connects to a change feed. So the requirements to be a source for Drasi are you need a queryable API and you need a change feed. So the change feed is the most important thing because that is what we use. That's our guarantee to you. We're going to hit your database as little as possible. So when a new continuous query starts, we'll bootstrap, so we'll do some initial querying, but after that, we don't query your database at all. We just take the change feed. So it's a key point of extensibility. We support graph databases, relational databases, sort of system configuration databases, but internally, we're sort of doing this translation to we've got a conceptual property graph model that we sort of work on internally, and that'll become sort of clear the reason for that in a minute. Reactions are at the other end. They're the sort of outbound, the impact side of Drasi. And this is the reacting intelligently part. So what do I do with these changes when I figured it out that something's changed? Well, often I want to just push it into some existing system. So we have a reaction SDK. It's another point of extensibility. So we can push into your normal infrastructure like event grids and Kafka queues and this kind of stuff. But we also imagine that people will be able to write very problem or domain specific reactions that just do specific things, like maybe they send an email or they send an SMS or they hook into some internal ordering system, that kind of stuff. So this is what Drasi provides to allow you to integrate with downstream systems once a change has been detected. So they're like sources and reactions they're just like integration technologies that we need. But the real interesting thing about Drasi is the continuous queries. And this is not a new concept. Perpetual queries, continuous queries, standing queries, these have all been around for a while. But we think the combination of stuff that we've brought together to make this happen is a little bit unique. So a continuous query is a Cypher query at the moment. We've chosen Cypher. We chose Cypher 2 years ago because there was good tooling for it, there was good support for it, and we felt it was influencing the graph query language, the GQL stuff that was being worked on by ISO. And indeed it has. It's been a major influence, and we'll probably look to support GQL in the not too distant future. But for now, we're using Cypher with some extensions that we've sort of added. But really what you're doing here is you're saying, like, I'm expressing an interest in a set of things, and I want to know when that set of things changes. So we're not sort of saying, tell me when this property has changed, or tell me when this, this item has changed. We're saying, tell me when this set of things has changed, and then wrapping it, basically eventing notifications around that. So I express what I'm interested in with the match and the where. So this is like the selection. So here I'm saying, I'm interested in employees that are connected to locations, that have incidents, that are active. Have I just lost? I've lost audio. Hang on a sec. I'm just turning it back on.
You hear me?
Can you guys hear me?
Yeah, I
Yeah,
can
I
hear
can
you.
hear you.
Okay.
I
All
can
right.
hear you.
Very good.
I have a question. What is it? So
Is this Victor speaking? Who's speaking?
this is Ricardo.
Oh, hey, Ricardo. Yeah, sorry. I see you now. Thank
Yeah,
you.
so this is a Cypher language. Can you give a little bit of a background on this language?
Okay.
I'm not familiar with this, so I just kind of
Okay.
maybe
Okay.
some other
Yeah.
folks are familiar or not. Yeah.
So Cypher is a graph query language, and my understanding is its origin is with Neo4j. It's a declarative language that they created for the Neo4j graph database, and then they published it as an open standard. I'm not quite sure when, but as Open Cypher. So they made the spec sort of an open standard, and then they've been growing sort of Open Cypher over the last few years and sort of maturing as a collaborative sort of community effort. It's a declarative graph query language. So if we look at this example here, they use these are patterns, right? So if you look at the match section here, this is like saying, these are the patterns I'm interested in. So I'm interested in the curved brackets are nodes and the square brackets are relations. So I'm interested in employees that have a relation of type located in to another node of type location. Right? So I'm interested in employees that are located in this location. And so as this match query executes, it's going to look for those patterns and say, hey, I found 50 of these where employees are connected to locations, and then the rest of the query sort of unfolds where you do the selections and the conditions and that kind of stuff. But here, what it's doing is it's saying, I've got this employee. Can you see my mouse when I'm waving my mouse around?
Yeah, I can see the pointer.
Okay. All right. So this first employee is saying, I'm interested in employee nodes that have a relation called located into a location. And then the comma says there's another second path expression. And this is saying, I'm interested in incidents, which is another node type, that have a status, which is a property of active, a status equal to active, and it has an occurs in relationship to a location. Okay. And because so when you look at the nodes, the thing after the after the colon is the type of node, so it's a location node, and this symbol before the colon gives it an identity, right? So I'm giving the location in this query an identity of L, and because the location is in the second path and in the first path, and it's got the same L, I'm basically talking about the same location here. So what this expression is saying is, I'm interested in employees that are located in a location where there's an incident that's active. Does that make sense?
What is the advantage of having this instead of like standard SQL? It's just that you can actually query relationships like for graph databases, or that.
What is are you asking about our use of it or the general use of it?
The general use, and I guess it would apply to your use,
right? So the general use of it is, graph querying is particularly useful for when you're dealing with hierarchical data instead of trying to write, hierarchical queries in SQL. When you've got, if you've got a team, a hierarchy of teams, team contains teams, contains teams, like that is a nightmare of relational querying to do that kind of stuff. Right. If you have, particularly for sort of exploration and analytics, like I want to do shortest path analysis quickly between these things, having the relations manifest in the graph and having a query language that supports them natively makes that easy to write. Yeah.
Yeah, in the case of Drasi, what it for like detecting events, is that better, or because the events are hierarchical, or what?
So for Drasi, we chose it because we wanted to be able to express really nice, simple, elegant connectedness between stuff, and we felt that it's almost like ASCII sort of art. Right, this sort of quite elegant. I'm drawing out the patterns, so I can sort of see. I'm talking about. It feels very intuitive. It felt very intuitive to us to use to just be able to say, I'm talking about employees that are located in locations. It's a sentence, right? It tells me what I'm looking for without having to understand SQL Server or SQL query language. It's also allowed us to do some interesting cross database connectivity. Like we can do queries across databases just with this. So we don't care, the writer of this query doesn't care where employees are or where locations are. There's some metadata in the background that is a mapping, but in the query where I'm just concerned about concepts and answering a question, I don't have to get into the nitty gritty of the join and how these things are joined. That's a separate problem.
Got it.
Okay.
I think this is super interesting because now with LLMs, you're also creating some of these things. So like I've seen cases where you created queries for structured data. So you actually have a natural language prompt, and then and actually give me like the employees in this location and whatnot, and with these different data sources. So like some LLMs even understand some of these languages, and so they might actually understand to cipher, right? And be able to.
I've done some experimentation. It wasn't terrible. Like its understanding of cipher. Of course, there's not as many examples of cipher queries as SQL queries, so it's not as good. But I think for a lot of the simpler queries that people will do, Drasi has a different focus. Like we don't do graph analysis. Like we don't do shortest path and and nearest neighbor and neighborhood sort of kind of queries. We're we're finding an easy way to express, I want to know when these connected things as a result set are changing, right? So just jumping back to this, that first part, the match and aware are sort of saying what I'm interested in. And then the this return is just the projection. It's saying what bits of that data am I sort of wanting to be in my result set, okay? So here it's saying, the question I want to know is which employees are at risk from some incident near them being dangerous? That's the question I'm asking, okay? And so when Drasi runs, when we run this query in Drasi, and that's all you really need to write in many cases. I just write that query, I publish it to Drasi, and we've got CLI tools, we've got some plugins for Visual Studio Code, etc. So you can write your queries and publish them to a Drasi environment. When it starts running, the query connects to the sources that it needs, and they need to be deployed. But it'll do this initial bootstrap process. So it'll get the initial set of data from the source databases. That is the only time we query your databases, to get that initial data. After that, it'll just listen to the change feeds, and it maintains this perpetually accurate result set. So it'll, in this case, maybe there's 4 people. When I run this query, there's 4 people currently at risk. And then as we're listening to these change feeds where source data is coming in, if there is a change that adds people to that result set, then what the continuous query does is it recalculates its result set and then sends out to all the subscribed reactions saying, hey, the result set has changed. So we're like up-leveling low-level source changes into higher-level result set changes, okay, and sending out a diff. So the continuous query spits out what's changed to the result set, whether things have been added, updated, or removed. So, if something, and one source change could cause many changes to the result set. If some element in the, like if the incident changes, for example, that could, if it goes from a high priority to a low priority, if it's sort of diminishing, that could remove many people from the result set, that one source change. So that would all be communicated to the reactions. And then the reactions do different stuff. And we sort of talked about before, it could just push it into a cloud event format, into an event grid. It could update a database. It could push data to a Signal R endpoint, so that gets distributed to endpoints. And we've got an example to show this in a minute. So where are we? Yeah, we're published, we're out on GitHub. Usable today, we've got a CLI, we've got APIs for managing Drasi environments. You can run it in anything from a dev container to a full-on Kubernetes cluster. You could run it on premise, you can run it on any cloud that you want. We've got instructions for deploying it to AWS, to the Azure Kubernetes hosted service, to some local like K3. Kind. So it's very flexible in terms of how you can start quite small, grow quite large.
So
Yeah.
Alan, I'd love to see an example.
Yes.
We are, just FYI, we are like a couple minutes out, unfortunately, on
Okay.
time.
Okay, I'm going to show this to you straight away.
And yeah.
So very quick, this example is a team trivia game. So multiple people can log on and they're going to answer questions about, trivia questions, right? In the back end, we've got 2 databases. One's a Postgres database, and this is just purely contrived, but it demonstrates the purpose. Left-hand side here, we've got a Postgres database, which has trivia categories and questions in it. And on the right-hand side, we've got a CosmOS Gremlin database, which has this graph of teams and players and answers to questions. And this sort of link here is fictitious. It doesn't really exist, of course. But the ability for us to link an answer to a question is just the ID of the question, okay? So totally separate databases, and yet we're going to create a system like this. This is a little complicated, but I'll go through it very quickly. On the left-hand side is this app, right? So imagine I've got this app, the black box, I've got this API and I've got this UI that you'll see in a minute that's calling in. So it's only the only thing that the UI does is really talk to the API, and it uses the API to get the next question, to submit answers from logged in users, and allow users to switch teams, which is a fun element of the game because you can switch teams at any time. So that's like a sort of typical kind of app that lives in the cloud. It talks to two databases, the ones we just talked about, Postgres and Cosmos Gremlin. So it's the API service is updating those databases. Okay. On the Drasi side, which is this sort of box on the right-hand side, we've got two Drasi sources, one for each of the actual databases. We've got 4 continuous queries running, which I'll show you in a minute. And we've got 3 reactions, which is on the right-hand side. One of them is a signal R reaction, which is every time those queries that it's connected to get changes, it pushes them out to this signal R endpoint, which then pushes them out to the UI. And if there's no questions, I'll just jump straight into this demo here. Let me get it up and running. Okay. Yeah. Okay, so I get to choose which team I join. It doesn't really matter. I'm going to choose team A, and it gives me a random name. So I'm Jabba Deselectura 12. Right, so I'm on team A. I'm Jabba 12. Okay. Let me know if you guys can or cannot see that. This blue box, it's just where the question is, and it's given me a question, 4 possible answers, and a way to submit an answer and a way to skip. I'm just going to skip for the moment. So when I skipped, what that did is it called back to the database and said, Jabba has skipped this question. And if I do just keep doing that, you're going to see that I'm now in this list. So these other panels, I've got a player scoreboard, which is player-centric stats. I've got a team summary, which is team summary stats, and I've got inactive players. So the player scoreboard, this is a React.js control. Each of these player scoreboard, team summary, inactive players, these are each a React.js control. And all they do is connecting to the signaler endpoint that we've set up for the system. And this is all they are, right? So that's the entirety of the code that maps that decides that. So it's this React control that we've written. It says, I want to connect to this endpoint, and I'm using this query. So this is the continuous query I'm interested in. And what this does is it basically data binds the contents of that panel to the output of the continuous query in Drasi is the result. So this is a continuous query. So this is running in Drasi. This is not live. This is just a representation of it. But you can sort of see we've got this match section, which is saying I'm interested in answers that are answers from a player, and that player is a member of a team. And I'm also in the second part of that match is I'm interested in answers that are answers to questions. And because this A and A here, this sort of connects these two paths together. But what this is doing, running in Drasi, is it's looking for this constant pattern. And every time a change comes in from one of the sources, and you remember that some of this stuff is in Postgres and some of this is in Cosmos, right? So all of this answer, player, and team, this is all in Cosmos, and the question here is in Postgres. So we're just, sort of magically connecting across these data sources and being able to detect when changes in either of them occur, because if any of this changes, it's going to update the results. If the answer changes, if there's more answers, if the question changes, if the player changes their team, if the player changed their name, if they could do that, it would always result in some update to this data set, which would then update the reactions, which would then propagate through the signal R, which would update this this UI. The rest of this, the return, so I'm saying I want the name of the player and the name of the team, but the rest of these are the aggregations that I'm doing to create the data for the table. So I'm doing real-time aggregations across sort of synthetically connected data that comes from 2 different sources and pushing it out to endpoints through a signal reaction. And you can see that when I'm probably still logged in here, maybe. You can see that like I click the button here and the update to my skipped number here is almost instantaneous. So all of that's happening in less than, fractions of a second. Okay. Do I still have time to talk about one more thing?
I might have to cut you off here, Alan. Sorry, we're
Okay.
5 minutes over, unfortunately. There is another half a slot on January 2nd. If there's
Okay.
specific, you can always come back. I think there's a
Okay.
lot of stuff here, and I'm sure more that we didn't get to as far as community and aspects
Mhm.
on that regard that we could dig into as well. So
Alan, you can also share the slides on the Slack channel, and yeah, we can put the slides also on the meeting notes.
Okay. Yep.
I
Will do.
see that you're actually applying for Sandbox, so
Mhm.
I mean, there might not be a requirement for you to come back and say all the community things in the meeting if you have them on the slides and that
Okay.
information is publicly available. But it's up to you, right? So it's up to you what you like.
Okay. All right. Thank you. Thanks for your time.
Yeah, thank you very much. This is very interesting. Yeah.
So yeah, thank you both so much. Thank you to K0s and to Drasi for all of your time today, and thanks for fitting into the reduced time slot, stressful presentation. But thank you all very much, and
Welcome.
please come back anytime to tag Runtime for other presentations as well from other projects. Always open to all.
Okay. Thank you. Thanks so much.
Yep. All right. Have a
Thanks
great
all.
day.
Thanks, guys. Happy holidays.
You
Bye,
too.
y'all. Happy